take a look at this problem based on geometry. The figure given below consists of a circle of diameter SQ, sides SR is equal to RQ is equal to 3 root 2 and the side TS is equal to 5. Triangle TQU is an isosceles triangle. Find the area of triangle TQU. Okay, so we have a circle over here and it consists of the diameter SQ. We have a triangle inscribed in this semicircle, and on this side we have an isosceles triangle with sides with angles 45 degrees and 45 degrees. Now this angle is equal to 90 degrees. So we have to find out the area of TQU, this triangle. Let's first look at the data given. The question states that SR, this side, is equal to RQ and that is equal to 3 root 2. So these two sides are equal and that's equal to 3 root 2. And this is the diameter. Now we know a particular fact about semicircles. This is a semicircle, right? And this triangle SRQ is inscribed in this semicircle. Any triangle inscribed in a semicircle has what? It has an angle of 90 degrees if it's touching the circumference. Is this triangle touching the circumference? Yes. So this angle is 90 degrees. So we have found that out. Now if this is 90 degrees and both of its sides are equal, then we know another fact, and that is this is an isosceles triangle and it's a 45 90 degree triangle. If this is a 45 90 degree triangle, then the hypotenuse will be equal to root 2 into x if the other sides are x. This is a property of a 45 90 degree triangle. What's that property? It's I've mentioned in the other problems, but I'll do it again. Its sides will be in this ratio. These two are the equal sides because it's an isosceles triangle, and the other side, which is the hypotenuse, will be x into root 2. So where's the hypotenuse of this triangle? It is the diameter of the circle. So SQ will be equal to x into root 2. What's the value of x? X is RQ and SR because x is the side. It's the sides of the triangle. And the value of RQ and SR is 3 root 2. So x is 3 root 2. So SQ will be 3 into 2 and that is 6. This will be 2. So we have the value of SQ. Let's update it in the figure. We have 6. Now we have to come to this triangle because finally we'll come to this triangle and we have to find the area of the triangle. So let's look at the question. The question states that the length of the side TS is equal to 5. Where's TS over here? This is TS and this is equal to 5. And we also know that this is a 90 degree triangle. So let's draw the triangle out. This is 90 degrees. This is 6 and the other side is 5. Now what is this side? According to Pythagoras theorem, we know that h square is equal to p square plus b square, where h square is the hypotenuse, p is the perpendicular and this is the base or the adjacent. So we have 36 because it's 6 square. We have 6 square is equal to 5 square plus y square. And what is y? Y is this part. So to solve for y, we take 36 is equal to 25 plus y square. So what will y square be? Y square will be 11. Okay. So y square is 11. Then y will be root 11. So now we have found out y. And where is y in this figure? Y is this part, TQ. TQ is y. I'm sorry if it's messy, but I just want to highlight in the diagram where TQ is. So it's one side of this isosceles triangle, and this is equal to root 11. Now that we have found out this information, we can find the area of the isosceles triangle easily. Let's draw the isosceles triangle. This is root 11. These two angles are 45 degrees and 45 degrees. And we know that in an isosceles triangle, if this is 90, these two sides are actually equal. So this has to also be root 11. So we have the base and the height. What is the base? Root 11, and the height is also equal to root 11. So we can easily find out the area using this formula, half into b into h. We have half into 11, and that gives us 11 by 2, which is 5.5. So we have found out the area of the isosceles triangle, and that is 5.5.